Thank you. Nicola Marsh is a research manager at SINTEF Energy Research. She's also center manager of the well-known and large FME center NCCS and the upcoming Giga CCS. Recently, she has published a blog on energy and CCS with the title Significance of CCS in Achieving Net Zero Emissions. Please welcome her on the stage. Please, Nicola, the floor is now yours.
Thank you. So, you can hear me well, I hope. Thank you so much for inviting me to speak today. The question I will attempt to answer for you today is on the screen. CCS, is it a climate initiative or is it an expensive distraction? And I'm going to start my presentation by throwing the question at you, the audience. Before I tell you what I think, I would appreciate if you go in this Menti and answer, is CCS indeed a viable and necessary climate mitigation tool? Is it an expensive distraction, or are you not sure? And not sure in this context can mean you're not sure the answer to my question, or you're maybe not even sure what CCS is. That's absolutely fine. So we'll just wait for some answers to tick in. So far, we're leaning slightly more towards the viable climate mitigation tool. Give you a couple. Oh, here they all come. Look at that. Wow. Okay. So good to know my audience, whether you're an audience of skeptics or whether you're on board with CCS. We have a bit of a mix, and I think that's very good. We should always be open to debating such topics. Okay. Now that I know what you think, I will tell you what I think. So I will be as bold to state no CCS, no net zero. In my presentation today, I'm going to try and answer both, or convince you that CCS has a very important role to play in reaching net zero, but also come back to the question about this expensive distraction part. So we'll look a little bit into how much does it really cost. Okay, I hope I don't have to convince you of the why. The why being the sheer volume of CO2 emissions that we have in the atmosphere, which have risen dramatically since the industrial, this still doesn't work, maybe. Yeah, okay, I can do it here. This dramatic increase in the emissions that we see since pre-industrial levels. They were previously fairly flat, constant, and we've seen this huge rise. And without me saying much more, I think we can just look at these images from yesterday's news, whereby we've seen this horrific flooding in Spain. And indeed, with that as a context, we are already seeing this increase in global temperature. So the Paris Agreement was agreed on, a legally binding international treaty on climate change that was adopted by 196 parties at COP in France in 2015. And it's been one of the drivers for this international push to get to reverse the effects of climate change. And as a consequence of that, we often hear about these net zero targets. They can be targets that individual companies have, or indeed countries have. So first, net zero. What is net zero? Well, net zero means massively reducing our gross greenhouse gas emissions to be as close to zero as possible, as illustrated on this graph. And then any remaining emissions, and that's a key part of my message, any emissions that we cannot reduce to zero, they will then be compensated with what we call gross removals. So gross removals go net negative, and then overall we end up with this zero. This can be a little bit overwhelming when we consider the challenge ahead of us. It looks to be rather enormous, and we need to break it down, I would say, into its component parts. And I will talk to you mainly about this gross emissions reductions today. I'm not going to touch very much into gross removals, although that is also a very important part of the solution. So if we look at reductions first, above me here, you can see three things written on the screen. Energy efficiency is essential. We should be using the energy that we have available to us as efficiently as possible. That goes without saying. We need to scale up clean energy supplies, be that renewables or indeed low carbon energy carriers. And then it says decarbonize. And decarbonize is what, because those other two on their own are not enough, what we need to do is to capture the CO2 emissions from those hard-to-abate industries, the ones that simply cannot use renewables to meet their needs. So decarbonisation using CCS is essential to get us down to net zero. If you don't know what CCS is, well, CO2 capture, transport and storage describes the process of capturing carbon dioxide from the point source. In this case, we have fossil fuels as our fuel source. We have an industrial facility or in an energy production facility. We're capturing our CO2 at that point source and we're transporting it and there's many modes of transport here. You see pipes, ships, trucks, trains, to a underground deep geological formation, a storage site. And we do that to permanently remove it. And the important word there is permanently. We want to get it out of the atmosphere permanently. So this is where we can enable gross emissions reductions. Again, that fall in how much emissions we're putting into the atmosphere. And I've mentioned this, and this is one of the whys. Why CCS and why not just use wind and sun and other sources of newer and cleaner energy in order to get fossil fuels out of the picture. Hard-to-abate industries are industries where it's extremely difficult to lower greenhouse gas emissions, and examples of that are on the screen: cement, iron and steel. And here it says alone these are responsible for 14% of our global emissions, 5 gigatons of CO2 per year spitting into the atmosphere because we need, and there's some nice images here, we need buildings, we need bridges, we need wind turbines and so on. So these are the hard-to-abate industries, and you often hear that hard-to-abate industry as a phrase connected to CCS, and this is why, for good reason. I've already mentioned CO2 emissions, the fact that concentrations are high. This is how much do we emit globally per year? Well, usually we emit over 35 billion tons of CO2 into the atmosphere every year. And to put that into context then, or to compare to what do we currently do with CO2 capture, transport and storage, well, we capture roughly 44 million tons globally per year. So CCS is already a technology that works. It's in use. It has been for many years. And in Norway, I tried to estimate, this also includes the Longship project, which will be operational next year. But in Norway, we have examples of projects that are already capturing and storing CO2. So it's a proven technology and it's a necessary technology. And this is the International Energy Agency's prediction of how much CCS we need in order to reach, again, our climate mitigation goals. And to keep on that theme, if you like, net zero roadmap, how do we get there? Well, now we're turning, what do we need to do in terms of CO2 captured per year in order to get that net zero curve down towards zero? So I've told you that we already capture 44 million tons a year. The estimates, and again, globally, and this is the IEA, that we need to reach in terms of capture and storage of CO2 going forward are rapidly reaching the gigaton scale or the billions of tons scale. So by 2030, you can see it already says 1,000 million tons. And that's then, again, even more rapidly ramping up towards 2050. We're up at the 6th gigaton scale. And these are the latest estimates. You do see variations in these numbers, but they do all come out at the gigaton scale. So that transition then from flatlining-ish, roughly in the last years, to suddenly ramping up is a huge challenge, but one that we are seeing development in. And again, this is where we need to get to. So that's globally, gigaton. What about Europe then? Zooming in on our continent, this is the Industrial Carbon Management Strategy. This was adopted this year, and it's come with these targets. What we need to achieve in Europe, I use the we cautiously, but in Europe then, I'll come back to that, we are the driver being the EU climate law. And in the EU climate law, it states that Europe will be net zero by 2050 and net negative thereafter. So how are we going to do that? So here we go. By 2030, we need 50 million tons of CO2 capture in Europe, and that needs to ramp all the way up to 450 million tons in 25 years. Just to be clear, Europe doesn't include Norway as of yet, or Norway are not a part of this industrial carbon management strategy in its current form. But Norway have had a very important role to play in terms of the state of CCS as it is today. So I work in SINTEF. In SINTEF, we've been working on CCS since the 1980s. In Norway, we have examples of operational projects that are actually doing this. So we have the Sleipner gas field offshore. Equinor have been storing CO2 since 1996. Snøhvit up in Hammerfest has also been storing CO2 since 2008. And now we have this very important picture on the bottom right. This is the Longship project, the first full-scale CO2 capture, transport and storage project in the world. Whereby we will capture from two industry point sources in Oslo. We have the Celsio waste incineration plant, and we have the Brevik Heidelberg Materials cement plant, both of which will capture the CO2, transport it by ship all the way around to the coast of Norway, and then via pipeline to an offshore site for permanent storage. This is a world first, and it's been a real important project in terms of what's going to happen going forward. You see the numbers on the screen, 1.5 million tons per year initially when it starts to inject next year, increasing to 5 million tons. Again, very important, but it's nowhere near the gigatons, so we need many of these projects. So I didn't tell you so much about who I am, but that was a nice introduction at the beginning. I work in SINTEF. I'm a research manager for a team working on understanding how flow phenomena works in the context of often CO2. And I'm also a manager of two research centres, or one is coming to a close and the other one is starting. NCCS is the context of, or the work we've done at NCCS will be the main focus on the rest of my presentation. So in an FME, Forskning Center for Miljøvennlig Energi, like NCCS, we do four things, or we work in four pillars. We research, that goes without saying. We do that to build excellence and innovation. That's our foundation. We do three other things. We also educate a critical mass of talented people. So we build capacity, and we've done so by educating over 35 PhDs in the last 8 years. We build and share knowledge, and this is one example in an arena like this. So we have webinars and other forms of sharing knowledge, and we get involved on a policy development front to make sure that the knowledge we build is actually involved in the policies that are being made. So that's the kind of, if you like, the backbone of an FME. And this is NCCS in a nutshell. We have all of our partners around the exterior of the screen, from our industry partners and users on the top left, our research institutes and universities on the sides there, and then our vendors and industry organizations. A big consortium of interested parties who are engaging with CCS. So we coordinate all of these, and we do so research in these 12 research areas. And this covers the whole value chain. So we research everything from what you see at the beginning, value chain and legal aspects, through to capture, tech, transport and storage. And of course, I won't have time to tell you about all of that today, but I will focus on the first of those 12 research areas. And we'll look at the work we've done on CCS. Is it really so expensive? So in this research area, we've done some techno-economic analysis to look at what's really the cost of CCS. And this 25 billion NOK that you see here, that's the cost of the Longship project. I just told you about the first full-scale project, which Norway has launched. And this is a 25 billion NOK investment, so it's not cheap. I'm not going to claim it's cheap. 17 billion NOK came from the state, and the rest was from industry partners. It isn't cheap to get CCS off the ground, and there's currently no viable business case. So it's not easy. But it is criticised for being far too expensive, and we decided to try to take a different perspective. So we looked rather at the cost. What would the cost impact of CCS be on the end user? And this is a bridge that we looked at in the study, and most people, you and I, tend not to walk into a shop and buy cement or steel and take it home and do things with it directly. We rather buy a product that has cement and steel in it, like a house or a building, or we cross a bridge like this one. So we wanted to understand what's the impact of CCS on the total cost of infrastructure like this. What's the cost benefit analysis? This is the longest continuous bridge over water in the world, I think. It costs $5 to drive over the bridge. And this case study looked then at what would be the cost on the implementation of CCS in the cement and steel production on this bridge. What indeed would be the cost to the end user? So I've told you this already. Cement and steel are big emitters, and they need fossil fuels to be able to drive their process. The challenge then for these industries is that if you implement CCS on a plant, then the cost for that industry is too much. It's too high. It's expensive. And the fear here is that this high cost would make such plants uncompetitive and would make their products perhaps uninteresting to the buyer. So we had a look at it. And indeed, when considering the complete value chain from cement and steel production, CCS implementation then only increased the cost by 1%, in this case on the right for the bridge, but reduced the overall carbon emissions by 60%, or 51%, sorry. So a marginal increase in cost to cross that bridge, but a big impact in terms of CO2 emissions reductions. So again, illustrating the importance of a better understanding of the cost versus the benefit of CCS implementation. And then another example of something that could perhaps be described, or I haven't heard it described, as an expensive distraction. To achieve emissions reduction targets, all mitigation measures are necessary. It's not a game of pick and choose. And this was one incentive that came from the government, was a tax incentive for electric vehicles. This is inspired, I should say, by the work of Ringrose et al. And they've looked into this paper by Camara, looking at what is the cost. So electric vehicles are very successful, very popular scheme, if you like. A rapid transition to having now reached over 82% of the market share in 2023 of electric vehicles. But how much has that actually cost? So the subsidies per car is around $12,000. And if you look at that per ton of CO2 saved, the abatement cost is about $700 to $1,400, depending on how you do this LCA assessment. Compare it then to Longship, the full-scale project in Norway, and the abatement cost for CO2 in the Longship project is considerably less, $240 per ton initially, and that will reduce as we get economies of scale, as that project starts to scale up into phase 2. So this incentive to have, the tax incentive for electric vehicles is all very good, and I think we're all positive to that. I wouldn't describe it as an expensive distraction, but nor would I then say that CCS is either. So what are we doing now? Well, this is a new project. I'm not going to tell you any more than this one slide, but then CCS comes to an end and we start a new project. And you see the title is bringing in something I've mentioned several times. Gigaton CCS is what we need. And this is the Giga CCS Research Center. So I will conclude with what I think. CCS is not an expensive distraction, rather than an essential climate mitigation tool. It's one of the necessary solutions to reach net zero, and that the most significant risk of not adopting CCS is the continued release of billions of tons of CO2 into the atmosphere. And I thought we could run this again. Has anybody changed their mind, was the question. And it's absolutely okay to have not done so. But if you go back in, you should, I hope, get the option of voting again. And for anyone who, I can do my shameless promotion, anyone who's interested in what we do in SINTEF, my team is currently recruiting. If you're interested in understanding or working with the energy transition, please look on our website or come and ask if you're interested in working for us. And I put some links here. I guess we'll share the slides to various interesting CCS sites. No, didn't work this time, but I think it's okay. That was the end of my presentation. Thank you.
Thank you so much, Nicola. Well, that was very interesting. Thank you. And I'll introduce our next speaker here. So Bård is a postdoctoral researcher at the Department of Interdisciplinary Studies of Culture, otherwise known as CULT. And he is also a researcher at SINTEF Digital. His postdoctoral work is on CCS, and it's part of this CaptureX project, which examines socio-technical drivers, opportunities, and challenges for large-scale CCS and establishing a full value chain. Through his work, he has interviewed a series of public and private actors, has done us the incredible favor of reading through lots of old policy documents, and he has visited locations where CCS is pursued, such as industry parks and key sites for the Longship project. In sum, this has provided him with a deeper understanding of the socio-technical complexities that influence large-scale realization of CCS. So with that, I give the floor to Bård. Please welcome him.
Yes, thank you, Amber. Thank you for the introduction. Yes. This thing here. Does it work? No. Okay, let's see now. Yeah, perfect. Yes, Nicola's covered the technical parts, and I'll try to cover the socio-technical parts of this. I was quite concerned when I got the instructions for doing this presentation from Amber and the rest of the people, because I was told that I didn't have to explain how CCS works. And since that's basically everything I will do for 15 minutes now, I thought that's not good. But I guess that the way I'll be talking about CCS is quite different from how Nicola was talking about CCS earlier. So I will kind of try to say something more about the ideas about how CCS should work. And to some of you, I suppose that might seem quaint, right? Isn't CCS just CCS? Doesn't this just entail taking CO2 out of the air and storing it? Well, yes and no. And to elaborate this point, I will discuss CCS from a socio-technical point of view, meaning that in addition to understanding the technology, I will also try to understand the social aspects surrounding the technology. And since we're in Norway, I suppose that most of you know at least something about the petroleum history of Norway. But in short, petroleum exploration began in the early 60s. In 1969, ConocoPhillips struck gold of the black kind, and this marked the beginning of the Norwegian petroleum activities. Norway actively developed strategies for Norwegianizing petroleum, both in the sense of building a domestic industry and in the sense of managing the resources themselves. Some of these principles were set out in this instilling from the extended recommendation from the extended industry advisory board or something like that. They set out 10 commandments for how to deal with Norway's oil, how to manage the oil resources. And through this very good, nice way of managing the resources, oil became something of a backbone for the welfare state in Norway. Revenue from large-scale energy-intensive industries had served that role since the end of the Second World War. So aluminium and not petrochemical, but electrochemical industries. But what's better than one backbone for the welfare state? That's of course two. And after finding oil, the petroleum activities kind of ran parallel to Norway's self-image as an environmental nation. And to the extent that petroleum was problematized in this regard, in relation to the environment, it was the problem of oil spills in vulnerable areas was the topic. So this is from a blowout at Bravo, I think. So yeah, everything's peachy keen until it isn't. Because in 1987, this report that I'm sure all of you know, it was published by the UN, and the report was helmed by Norwegian Prime Minister Gro Harlem Brundtland. And after this report was published, our government, of course, had to act in accordance with the report that she had helmed. So in 1989, Norway becomes the first country to establish a emissions reductions target, the so-called stabilization target, which says that emissions should be stabilized at a 1990 level by 2000 and then reduced. It's published here. And yeah, here you see the target itself. And yeah, that was the goal. And 6 years later, Norway would also become the first country to walk back their emissions reductions targets. So I guess we were also a climate pioneer in that regard. But of course, the growing attention to CO2 as a problem, that's also a problem to what's become Norway's core industry, right? So, and it's a problem for Norway's self-image as a green nation. So how do you deal with that? Well, one way of dealing with it is to do what Norway did, to plan for constructing methanol plants, to plan for building gas-fired power plants, all of which would significantly increase domestic emissions. This, of course, isn't something that everyone thinks is a good idea. So since the 1970s, most of the gas, or all of the gas from Norway is piped to the UK and Germany. But by the mid-1980s, the engineers in Statoil, I suppose, and other companies have managed to solve these technical problems of getting pipes across the Norwegian Trench, which is this deep underwater fjord outside of Norway. In 1990, it is decided that the gas would be landed at Tjeldbergodden, 3 hours south of Trondheim, and in the parliament, discussions turned towards utilization. So what do we do with the gas now that we've got it ashore? And the question is, should the parliament grant permits for gas-fired power plants? Should it grant permits for the methanol plant, or both? And of course, the environmental movement and sympathetic political parties such as the Labour Party, the Socialist Left Party, the Christian Democrat Party opposed these projects because this would cause a rise in domestic emissions, which would not be in holding with the stabilization target. And this controversy keeps on for a couple of years, but ends in a compromise where the parliament decides to grant Statoil a permit to build a methanol plant, but they shelve the plans for the plans for the gas-fired power plant. But in the years to come, from 1992 and onwards, there is this discernible shift in how Norway thinks about climate policy. Rather than reducing domestic emissions, the point it turns to the idea of reducing emissions where it's most cost efficient. So rather than act nationally, the idea is that you should think globally. And this shift in reasoning, I think, made the next controversy regarding gas-fired power plants play out quite differently than this first one. And this is also where CCS enters the image for the first time. Sorry. The second controversy about gas-fired power plants kicks off in 1994 when Statoil, Statkraft, and Hydro get announced the Naturkraft project, which is where they sought to develop a gas-fired power plant again. And predictably, this also became controversial as it had been 2 years prior. But the prospect or the interest in building a gas-fired power plant was justified with reference to a looming power deficit in Norway, but also with reference to the recent integration of the Scandinavian electricity market. So this integration meant that that Norway could produce power using relatively clean-burning gas-fired power plants, which could, through the integration of the electricity markets, remove emissions that came from dirty Danish coal-fired power plants. So in this way, Norway could realize the goal of utilizing gas domestically, while also arguing that they were contributing to climate change mitigation in Scandinavia. So here you see this prime example of this thinking globally, or at least thinking Scandinavially. And this controversy regarding these gas-fired power plants takes a consequential turn in the mid-1990s, much because of this guy. Some of you might know who this is, but this is Fredrik Hauge, leader of environmental NGO Bellona, who suggested that gas-fired power plants could be equipped with CCS, and thus becoming essentially emissions-free. And with this idea, I think Bellona shifted the terms of the debate altogether, because rather than discussing whether to build gas-fired power plants or not, the politicians turned to discussing whether such plants should be equipped with CCS or not. And throughout the 1990s, CCS was able to hold together political coalitions containing parties who had diametrically opposed views on gas-fired power plants. For example, the Conservative Party and the Christian Democrat Party. So in this controversy around gas-fired power plants, CCS was a component of a larger debate regarding gas-fired power plants. But this debate is important for the rest of the history for CCS for two reasons, I think. First, because it helps illustrate the thinking globally logic. And on the other hand, or second, it represents the moment when CCS caught the imagination of Norwegian politicians. And as Nicola kind of indicated already, it hasn't really left their imagination since then. If anything, it's been strengthened. And so to the second phase of Norwegian CCS history, which starts in the late 1990s or so, because then the Norwegian state begins providing increasingly more funding for CCS research, or as it was often called in the white papers and stuff at that time, environmentally friendly gas technologies. And this gradual institutionalization of CCS, this culminated in the establishment of Gassnova and the Climate Research Program in 2005. And this institutional setup prepared the ground for building a gas-fired power plant at Mongstad, where Statoil was granted the permit to build a gas-fired power plant on two conditions. First, that the government, Statoil, and lots of international partners would build a test center for CCS technologies, the test center Mongstad that Nicola also mentioned. And second, that after the gas-fired power plant was built, it should be retrofitted with full-scale CCS facilities, which the government would fund. So domestically, CCS helped justify the construction of the Mongstad gas-fired power plant politically. However, there was also a quite different justification for this facility and for CCS, and this was elaborated during Prime Minister Jens Stoltenberg's 2007 New Year's speech, which is a key event in Norwegian CCS history. Suppose many of you already know this, but this speech is often referred to as the moon landing speech, and Stoltenberg spends, I think, 4 out of 15 minutes talking about CCS. And of course, he compares CCS to the US moon landing. He says it's Norway's moon landing. And he frames CCS as Norway's contribution to global climate change mitigation by saying, when we succeed, the world will follow. So again, you can see this idea of thinking globally, that we should contribute to global climate change mitigation. But, well, we don't have to reduce emissions at home. We don't have to even stabilize domestic emissions. We can continue doing gas-fired power plants, for example. And as many of you maybe also know, this turns into the moon landing turns into a crash landing. Costs kept mounting, and the Labour government shelved the project in 2013. In 2014, the Mongstad project was subject to a public hearing, where this photo is from. And during this hearing, it was quite interesting to read, I thought, because Stoltenberg time and again stated that the Mongstad project had succeeded. The technology had been proven, and this, according to him, was the main purpose of that project. Now, the technology could be implemented elsewhere, even if it wasn't implemented at the full-scale facility at Mongstad. And again, you see this idea of thinking globally, of contributing to global climate change mitigation without necessarily doing it at home. And I think it was also interesting to read the end of Stoltenberg's statement, because this phase of Norwegian CCS history kind of started with the moon landing speech, and he ends his statement at the hearings by paraphrasing Neil Armstrong. He's recounting the opening of the Mongstad test facility and recounts how everyone present felt that opening this facility was a big step for global climate efforts. And then we arrive at the currently ongoing phase in Norwegian CCS history, which is centered on Longship that Nicola also talked about. After this high-profile failure of the moon landing project, one might expect that the interest in CCS would wane or waver at least. But in late 2014, a year after the plans for the full-scale facility at Mongstad were cancelled, the Conservative government began setting up a new CCS project, and this resulted in the Longship project. It was presented in this white paper from 2020. As Nicola told us, the Norwegian state provides 16.7 billion NOK for the project in a bid to establish this full value chain for CCS in Northern Europe. CO2 is to be captured at Heidelberg's cement plant in Brevik and at the Klemetsrud waste-to-energy plant outside of Oslo. And I think it's notable that these two capture projects are in hard-to-abate sectors rather than fossil projects. We may talk more about that later. And then there's the Northern Lights joint venture, which consists of Equinor, Total Energies, and Shell, where this venture will run the transport infrastructure and the permanent storage site here in Øygarden outside of Bergen. And Longship, like the two projects I've discussed previously, is also characterized by this dual orientation. So abroad, the Longship project is promoted as a boon to European industry. It's a way of decarbonizing European industry. And emitters in a 1,200-kilometer radius around this storage site are invited to store their emissions under Norway's continental shelf. But then there's also how it's framed domestically, and that's quite different, because the functioning market for CCS is also seen to offer new business opportunities for Norway, relating both to CO2 storage, of course, but also natural gas production. So in 2023, Equinor signed this memorandum of understanding with the German energy company RWE, where Equinor will provide RWE with natural gas which will be used in hydrogen-ready, but not hydrogen-using gas-fired power plants. And the memorandum also included an option agreement for blue hydrogen, that is hydrogen produced from natural gas where the resulting emissions are captured using CCS technology. And in this concept, the blue hydrogen would be produced in Norway and then piped to Germany through a newly constructed pipeline. But the hydrogen component of this memorandum was shelved last month with the rest of the agreement remaining in place. So in other words, Norway or Equinor will continue selling natural gas to Germany. And this shows how CCS is kind of served, at least. I wouldn't say it was used, but it served to legitimize this project and continued natural gas extraction. So the natural gas deal included this blue hydrogen component that was shelved rather quickly on account that the framework conditions, the supply and the demand for hydrogen wasn't sufficiently developed. So the parties of the memorandum were left conducting business as usual, basically, buying natural gas from Norway and piping it to Germany. And so the point of this historical run-through is to try at least to provide a clearer understanding of the different ways CCS has worked or has not worked as a means, or in Norway, in Norwegian politics. So in each of these three phases that I've discussed here, CCS has functioned as this means for navigating this core tension in Norway between the climate and fossil fuel extraction. So in the first phase, we saw gas-fired power plants being justified with reference to the dirty Danish coal-fired power plants, which represented Norwegian gas as the, relatively speaking, climate-friendly alternative. While domestically, CCS catered to the political needs of these different parties seeking to build alliances, and where some sought gas-fired power plants, whereas other did not want them, but CCS helps glue these coalitions together. In the second phase, the development of CCS technology was presented as Norway's contribution to global climate change mitigation efforts. But domestically, again, you saw that CCS justified the development of the gas-fired power plant at Mongstad. And then in this ongoing third phase, the establishment of a full value chain for CCS in Northern Europe is presented as Norway's contribution to decarbonizing Europe. But domestically, the government has made it clear that beyond Longship, Norwegian industries won't really get anything near that kind of funding for CCS projects in the future, at least not in the near future. Simultaneously, we see that actors like Equinor explicitly use CCS as a means of legitimizing business as usual. And I don't know if this duality that you see throughout CCS history in Norway, if it reflects a guilty national conscience, or if it's a kind of savior complex, or whatever I'm not a psychologist. But what I see is that Norway repeatedly uses CCS to navigate this tension between climate and fossil fuel extraction. And I think we can also see that Norway often, if not always, concludes that it's sufficient to contribute to emissions reductions elsewhere, that it's not necessary to at home. Thanks.
Thank you, Bård, for this interesting and very critical presentation about CCS. Now we welcome both speakers to the stage to have a common discussion about it. Maybe we kick it off that Nicola answers some of the key concerns which Bård has raised here.
Wow. Okay. You raised a lot, Bård. I think what you took us on was a trip down memory lane. And for those of us who were here all the way back then, but I wouldn't disagree necessarily. You were talking about Norway's domestic emissions. It's challenging in Norway in terms of CCS because the industries we have are spread and distributed and the emissions they have are low. So it's hard to get point source capture emissions from those industries necessarily and gather them together in a cost-effective way. But I think I would like to say, you're mentioning about Norway and the history. I mean, we have had highs and lows. There's no doubt about it. CCS has been interesting and it's been not interesting again. And now it's on this high and it looks like it's accelerating. I would say Norway's role globally is undoubtedly, we've been a pioneer, we've been a front runner. And without what Norway has done, I would say CCS wouldn't be in the position it's in today. Globally, I would go as bold as that. The challenge for Norway now is to not lose momentum in the sense that other countries are taking off. CCS is becoming interesting. You mentioned Europe, decarbonizing Europe. I mentioned the industrial carbon management strategy. How do we make sure that Norway is still one of those front runners? But we have been essential in developing CCS as a climate mitigation tool, no doubt about it.
Just a short comment.
Yeah, please.
I'm looking at the history. I'm not sure I agree with that the interest has ebbed and flowed because it's been quite consistent in the mind of Norwegian politicians. I guess public interest and public interest and media interest around it has varied, but like with the Mongstad crash landing, I suppose, they were straight back at it, not a year after the last project failed. So I think it seems, or to me, it seems like there isn't really a variation in interest in at the political side, anyways.
Okay, 'cause I think maybe I'm talking more globally and you're maybe more Norwegian or domestic focused, but certainly on a global front,
Yeah.
we've had highs back, in the early 2000s, and many projects that were announced, and then those projects were cut, and then you have this kind of dips again in terms of how many actual projects were planned to come into development. And now we have many, many projects globally.
Nice. Thanks for kicking off a interesting discussion. And I'll just remind everyone to please sign into the Menti and upvote the questions you want to hear. But I will start off with the first question, which is is mainly directed to Nicola, but of course we'll give Bård a chance to answer. If CCS is mature and proven, what are the main research and development needs?
Wow. Well, I mean, it depends and it's complicated, but CCS is a technology that's being used. I mentioned the Schleipner gas field, and there's many projects that use CCS and have done historically. But as you're rolling it out at a larger scale, you need to now look at upscaling, and that brings with it many challenges. If you look in the subsurface, for example, in terms of actually storing CO2 when you inject, or anything that you do in a singular path, if you like, you have one point source, one pipeline, one injection, that's fairly simple. When you start to introduce more and more lines into that chain, then you introduce complexities. For example, how are we going to measure which CO2 is flowing everywhere? That's something that we research. It's fairly new research. We're looking at sensors. How can we actually account for the CO2 moving around? Because it's the amount of CO2 moving around that gives the ETS, gives companies, they need to know exactly how much is moving about. That's one thing. And then you start injecting more and more CO2 into a site. What will be the impact in that reservoir in the geology subsurface? So you're now looking at pressuring up an area more so than we've done prior. So there are many aspects of it. We also have several capture technologies, so it's not just one. At the moment, most of the technologies are of a similar type, but there are many other capture technologies coming onto market. So it's not sort of being researched and that's it. There's several challenges we still need to solve.
Thank you. So the second question will be, industrial parks are often cited as an ideal place for implementation of CCS. In your experience, what is the reality of implementation, for example, in Norway?
Industrial parks as in clusters of industry.
Exactly.
Well, I mean, I've talked to you about expensive. Is it expensive? Is it not? It is, of course, expensive. I'm trying to compare it to other technologies when I say that it's not a distraction. It's not as expensive as maybe others, but yes, it's expensive. So any industry, be it a park or a single site, has to have enough investment, enough capital to be able to get this off the ground. And that's the main challenge. Where's the business case? At the moment, there isn't any profit to be made. So actually investing is a huge challenge for any industries. And then, of course, if you cluster industries together, you actually start to maybe make your business case better. More industries coming together to share cost.
Yeah, thanks. And then I know Bård has been to visit some of these industrial sites. So
yeah, and I guess I understand where that idea of cost efficiency comes from, that if you pile lots of CO2 and make some kind of collaborative arrangement around CO2, it will become less expensive for each industry or each plant. But what we have seen in Capture X is that there's the constitution of the industry parks, the different kinds of industries that are present there. It's often a kind of challenge for those kind of efficiencies because CCS is so, currently at least, so expensive, and because there is usually one or two plants that must have CCS, whereas it would be nice to have for the rest. Yeah. That means that the other ones prioritize other kinds of decarbonization options first, and then figure that, okay, well, maybe we'll end up with, I don't know, 100,000 tons in the end, and we'll do CCS then because then it has matured. So it's kind of a lot of the industries can or none of the industries can wait, but you know what I'm saying.
Yeah, no, I agree. So the bigger, or at least the more you can agree that we all go in together at the beginning, the better it will be in terms of cost sharing. If that's not the case and one company has to go ahead of the others, then they carry more of the cost. So it's who carries the cost at the front end of the chain, and they take the most risk. So it's very difficult to get these clusters. They're a very good way to sort of pull emissions, but it's very challenging. And another thing about the research, what should we research? If you have several industries, all with different streams of CO2 coming into a shared facility that then gets shipped offshore, for example, you have impurities in those streams. And this is a challenge. How do we then get the impurities out of the streams and then get that CO2? Because there's very clear and strong specifications as to what you can have of different chemicals in your flue gas. So there's a still ongoing research topic in terms of other challenges associated with clustering.
I have a
two
question.
Streams, yeah.
So you focused a lot about industry CCS in your presentation, and Bård was especially criticizing gas power CCS. So my question would be connected to that. If the levelized cost of electricity of gas power CCS would shrink to, let's say, 100 euro per megawatt hour, more or less what offshore wind maybe will cost in the future.
Yeah.
What is your selling point? Why should we invest into gas power CCS instead of offshore wind, for example, or both?
I don't think you can choose one or the other. I think you have to look at all. It depends on a case by case. That would be the most honest answer. So I don't think there is an answer. CCS it used to be more of a gas powered by power plant and CCS interest, I would say, and it's less so now in terms of my experience. It's more to do with how to abate industry and how do we get those industries to abate their emissions. But the answer to that question would be case by case. I don't think you can say one over the other.
And give Bård a chance to talk, because I get the feeling he doesn't think he was being so critical.
Yeah, I think it's fascinating that you interpret me as very critical about this whole thing. That's not been my intention, at least, but I guess the facts seem before. No, but yeah, I also think that there's I think that there's been a quite conscious shift from fossil-based projects in the previous phases of CO or CCS in Norway towards hard-to-abate industries. That seems to me, at least, that seems to be a very clear thought-through choice from the state and from the other partners in the project. But of course, there are also other places in Europe you will still have fossil-based CCS projects, so it's not. But I agree that it's less of a focus. It's shifting towards the hard-to-abate industries.
Yeah. And then we would like to give you the chance to ask a question with your voice instead of your thumbs. So maybe taking one or two questions from the audience. Does anyone want to vocalize their question to our speakers?
Yeah, my question is how far is it from being a commercial solution that you don't need public funding?
Oh gosh, that's a good question. Well, I mean, Norway has already said there won't be more funding for CCS projects like the Northern Lights. That was the funding we've been given, and now we have to try and make it work on our own. So in Norway, as far as we know, in the future, there is no more public funding in the terms of subsidizing, an implementation project. But no, we're certainly not at the stage where CCS is a commercial industry. So having a solid business case, having either an incentive to do it in the sense that you have some sort of economic incentive, or being forced to do it. And that's what we're seeing. I wouldn't say we're forcing anyone to do it yet, but we have the Net Zero Industry Act, which has come in Europe. And in that act, they've described the obligation of oil and gas companies to actually work up storage sites. So they actually have to do this now. It's not anymore sort of, is it economic or not? It's becoming more and more like a license to operate. So The business case is still not there. But as we see the cost of emitting CO2 rise, then we start to get to a point where it actually becomes more economically sensible to capture and store CO2. So we hope it's coming.
Yep. Thanks. Nice. And I don't know, we are 2 minutes over time. Should we take one more question, or you guys? Yeah, maybe one more, and then we will move on to pizza. But Bård, did you have a response before we get to the next question?
It's been talking a lot about electricity from land or CCS at the oil platform. What is your opinion, advantage, disadvantage?
You mean electrification from land as opposed to CCS directly offshore?
Yeah.
Yeah. Again, it will be case by case. I mean, that's a big topic because not everybody's keen that we take our electricity steal it from land and send it all offshore to decarbonize the oil industry. I understand that's not also necessarily a popular choice. It's the cheapest choice. So in terms of a company choosing which one to choose as an oil and gas company, then they will most likely choose the cheaper one. And the more people that electrify, some platforms are electrified, then it's easier for neighboring platforms to piggyback onto that existing line. So it becomes more challenging to do it. But CCS offshore has a role, and it's technology that's being developed. So it's again, it depends on the case, on the platform. But I think it's a debate we'll see coming back. And I hope it's a debate we have more in the future.
And then two questions if you want to respond on. There was the one about the business case, and then this one about electrifying the.
Yeah, I don't think I have much to add on the last one there. You said it. It depends, and I can answer the same way in that regard. Regarding the business case, I think it's interesting that at least a simplified version of when CCS will kick off is that when the ETS quotas become sufficiently expensive, then the lines will cross and it will become cheaper to do CCS. But during one of my visits in one of these business parks in Norway, we talked to a plant owner who was saying that, well, at that point it just means it's expenses to us anyways. So if we can't manage to buy enough quotas, we can't manage to buy CCS anyways, so then we're stuck with nothing, or we'll have to move our plant elsewhere, where the environmental regulations are more lax, or something like that. So you have those kinds of problems as well, which seems to kind of also relate to the and I don't know, not vagueness, but the signals that Norway won't really fund any more implementation projects. So I'm not sure how they figure out that this will. I figure that this will work out, but that's the dates. Well done.
All right. Well, there are a lot of interesting questions here that I hope you'll stick around with and ask of our speakers and get to know each other. And we won't stand between you and the pizza any longer. But before we move on to that, please just give a big round of applause to our speakers for donating their time and expertise. Thanks. And thank you so much for coming. Please come and introduce yourselves, say hi, and stick around.
Hydrogen.
Oh, yeah. And our next seminar is about hydrogen. It's in 1 month on the 28th of November.
Exactly.
Yep. Same place, same time. So we hope you'll join us for that one as well.